So the first topic that we're going to learn in DS2 is called set theory. Okay, sets are a super fun and useful tool that you're going to sort of start learning about, and you're going to find that especially when you deal with data sets are essentially like this general idea of what, like, there are sort of like they're a smaller idea of what a set actually is. Okay, so so firstly, like I mentioned like last week, right, that people should go read through this stuff. How many people, you guys can put your hands up. There's a little hand symbol here that you can do called raise hand. So how many people actually read through the two notebooks? So before, so I'll give a general definition of what a set is, and then what I'm going to do is I'm going to ask you guys questions, and don't worry if you get the answers wrong. This whole process is about you learning. So I want you guys to interact and sort of think about questions as I ask them and answer them, right? Because see, the content is all here, right? You can just read through and you can understand what's going on. But what is more important for me is that you guys understand at a fundamental level, like what's happening, because you want to be able to use this information in some way or the other, right? So I'll give you the general definition of like what a set is. Okay, a set basically is nothing more than an unordered, as it says, like it's an unordered collection of items, right? So think of it like having a box. Okay, so when you have a box of fruits, that's essentially a set, right? It's nothing more than a set. Okay, because what you have is you have a collection of fruits which have no specific order, right? So you have oranges, apples, pears, grapes, whatnot. So it's a set of round fruits, right? So they're all approximately round. So that's it's nothing more than that, right? So mathematically, you would just write it as some capital letter, and then that's like one of the examples that we've given you, right? So here you have like a bunch of fruits. That's a set. So so I can have different. I can have like tinier versions of the set, right? Which is essentially like I take like a whole bunch of fruits and then put that into a smaller box, right? So I have a big box and then I have a tiny box, right? So and that's another set, right? So suppose from this set I take the apples, peaches, and bananas, and I put it in another box, right? So now I have two different sets, right? One set that contains apples, bananas, and peaches, the other that contains grapes, bananas, and mangoes, and bananas, right? So and the idea is that I can have like in all of this, there's no order, right? So there's no information about what sequence the objects came in. Like I don't know whether I put the apple first or the banana first or the peach first, right? That's the idea. It's almost like a snapshot, right? So you don't care about like what happens over time. You only care about what you're looking at that specific moment, right? So that's the basic, sort of definition of the set. So there's basically really sort of two things there. One is the mathematical definition. The other is the data structure definition of the set. So I'm just going to use a Google Colab here because it's just easier to sort of play around with. So Google Colab is another kind of like Jupyter notebook that you can access for free. Yeah, so it automatically comes, like it's part of Google's ecosystem of apps that it provides. So what did we say? We basically said that there are basically two definitions of sets. Okay, so there is two definitions of sets. Okay, so one is the mathematical one, which is it's an unordered collection of objects. Okay. 2 is sort of the Python definition of a set. Python 1, which is a data structure. Okay. So the Python definition of a set, right, is pretty much, it's very, very close to the mathematical definition. In fact, the Python definition is inspired from the mathematical definition of a set, right? So if the mathematical definition of a set is bananas, apples, oranges, pears, and so on, right? The Python definition of a set is literally just that. Okay, so banana, apple. So if I just do type of S, oops, what happened here? Oh, yeah, okay. Right. So if I do type of S, I'm essentially doing that. So so the error that I made there was that I have to actually give it as a list. Okay, so I have to declare a list called list with all the objects that I care about, and then I essentially declare that as a set, and that's essentially my set. Okay, so the first sort of question I'll ask you guys is, if I have something like this, right? Banana, 2, star. Would this be considered a set? Esther, you wanna take a crack at it?
Yeah, it's a set of various items.
So, I mean, you can essentially pull a set of similar items from this, right? But actually speaking, this wouldn't be a set, okay? So the reason why this wouldn't be a set in sort of a mathematical sense is you have objects here that do not belong together, right? So you have a special character, you have a number, and then you have these objects. Okay, so you're perfectly right in the sense that I can say that this is the set of all things, right? Set of all things, and then I can define like a giant set and say that, okay, all numbers in the world, all fruits in the world, all special characters in the world are part of my set of all things. But really speaking, in a set, what we want to always do is we want to essentially only keep objects that are similar to each other in a set. Okay, so basically the simple idea here is that in a set you want to have objects that are of similar type. Okay, so that's why when we define this, we had like banana, apple, orange, pear, they're all fruits, right? So can someone give me an example of a set of numbers? Any set of numbers?
5, 10, 15, 20.
Yes. So it's interesting you say that, right? So 5, 10, 15, 20, right? So what I can actually do is I can continue this, right? 25 and so on, right? So this is actually the set of all numbers which can be divided by 5. right? These are all the numbers that can be divided by 5, right? So I can have, so this is actually a very good example. So this is a set, right? Because it's a collection of objects. And the thing is that it doesn't matter what order it's in, right? And this is actually an infinite set, okay? It's infinite because I can keep finding numbers to divide by 5, right? I can keep going on and on and on, right? So this is an infinite set. Right? So can someone give me an example, another example of an infinite set? Something that's not divided by some number, some other type of set. Rebecca, can you think of an example?
So something that's not divided by a number or multiple of a number. Is that what you're?
We can take the multiple of a number. So let's just say set of all numbers. Well, so when you say multiple of a number, you're only multiplying it by one number. Okay, so maybe what we'll do is we'll just do multiple of 2, right? So what is 1 times 2? 2, right? So then have 2 times 2, have 3 times 2, and so on, right? So there are some other obvious examples, right? So like set of all negative numbers, right? They're infinite. You can have like -1, -2, -3, right? So and these are like super simple examples, right? There's nothing super fancy about any of this. That we're just looking at collection of numbers, collection of objects, like, you know, so these are like examples of sets. You have finite sets, you have infinite sets. So this idea or the definition of a set is clear, right? Any questions about how you define a set, like mathematically, please? Okay, so between the difference between dictionary and set, we'll get to that. Okay, that's a very good question. So mathematically speaking, this is what a set is. Okay, now when we come to how we represent things in Python, right? In Python, so here's a fun question. Would it be possible in Python to represent an infinite set? Brian, can you think of is there a way to represent an infinite set of numbers in Python? To hold an infinite set of numbers?
No.
Yeah, you're right. So no, there is no way of holding an infinite set of numbers in Python, right? Because if you have an infinite set of numbers, you're just going to run out of memory, right? You're beyond a point, you're just going to run out. So everything in Python essentially is finite, right? So your sets are finite. So you're always going to have like a sequence of numbers that essentially have some fixed length, right? So if you look at my set S, right, what I'm gonna see is that it'll have a fixed length, right? And when so this is a data structure, just like a list or a dictionary, or you know, or an array, like a NumPy array. A set is a data structure. What is the role of a data structure? The role of a data structure is to hold data, right? And it's to hold data in a specific way. Okay, so a list holds data in the sense that, you know, I essentially have like this string here is stored in some memory address. You know, this string here is stored in some memory address, and so on, right? And you know, the ordering in a list, right? Like the ordering in the list can be easily controlled. Okay, And that's sort of the benefit of a list. If you look at a dictionary is different in that context. So this is like coming to Mari's question that in a dictionary, right, you cannot define it the way that you define your set, right? So if you try to do something like you need a key, right? You need a key and a value, right? So the benefit of having a dictionary is that you can very, very quickly access a value given that you have the key, right? So for instance, a dictionary for something like my array L would be something along the lines of B is L0, A is L1, and then then I have O is L2, and so on, right? Like that's a dictionary. So in a dictionary, you have a key and a value, right? And again, these are unordered. There's no specific order to this, right? There's no way that B comes first or A comes first or O comes first, okay? So this is not a set, right? Because so what you can do is you can create a set out of the keys, right? You can create a set out of the values, but they're not really like, it's not really a set, okay? Because you need to provide a value for the key in order to get the value. So you need to provide the key in order to get a value. In case of a set, that's not the case, right? So in case of a set, if I just do 0, right, it's 0 will be my whatever is my element, right, my 0th element. So that's where you have this whole idea of a set where it's more like a list, not like a dictionary. And that is the whole idea that you have to take away from it, like when it comes to Python, right? It's more like a list and less like a dictionary. Okay, so dictionaries are very, very unique. They're very powerful. They're very useful, primarily because when you access a specific value, right, in the computer's memory, what it's doing is it knows, like, it creates something called hash table, where it knows like that B points to the value banana. Okay, so that relationship, that one-to-one relationship between a key and a value exists. That does not exist in a list or in a set. Okay, I mean, it kind of does in the sense that suppose when you do, so when you do S0, right? See, it gave you an error, right? So sorry, when you do an L0, you're going to get some value here, right? But when you do S0, you're not going to get any value, right? Because a set is not ordered in the same way that a list is, right? So how do you access like values in a set, right? So that's something that you have to think about. Any guesses? Like, how should you access values in a set? For the people who read through the whole thing, how do you access values in a set? So do you think that this will work when accessing the values in a set? We can't hear you if you're talking. Okay, I'm just gonna run this and see. So you see that I was able to access the values in a set when I was doing this, right? But when I tried to do this, it fails. Right? So this kind of goes close to that mathematical definition, is that there is no order of elements in a set. Okay? And that part is super important to understand, because when you start working with sets, you can't just simply, you can't just simply start manipulating them like it's a list. Okay, so you have to think about like, okay, how do I add elements to my set? How do I remove elements from my set? You know, what precautions do I take so that I should be able to access the values in a set? Okay, so all these sorts of things you have to think about when you think about like using sets, right? But they're extremely powerful, and we'll start talking about like how powerful they are in this part. So but everybody got that part, right? So to access the values in a set, you'll have to use something like a for loop. You can't really access those values directly by indexing it, right? So that part is clear, right? Any questions on this? Okay, so if that part's clear, so let me move on to the next part. So let me see. Yeah, so adding and removing things to a set, right? So suppose I have my set here, right? My set of apples, oranges, and whatnot. Yeah, so suppose I have my set, right? So the way that I add to my set is I just do add. Oh, okay. So this is a fun one. So I add grapes. Okay. So when I print S, what should I see? Anyone? When I print S, what should I see?
You should see the letter S within that set.
You should see the letter S in the set.
Oh, I mean, sorry, grapes.
So I should see only grapes, or what should I see?
Or all the sets in S plus grapes. Sorry.
All the elements in sets, not all the sets. So each of these are called elements of the set. Okay, the banana, apple, orange, pear, right? So
Yes,
they're
sorry,
called
that's
elements. No, that's fine. That's good. So they're called elements of a set. So when I do this, I should essentially see, and you're right, like you should see all the elements with grapes, right? Now I'm gonna do something else.
just the elements of S.
Just the elements of S. So will I see 2 elements of banana?
No, since it's already exists, it doesn't add it.
Exactly, right? So this part is really important. You cannot have duplicates in a set, okay? And that makes set really powerful, okay? Because suppose, so I'll give you an example. Suppose I have a data set, right? So I have a data set where I have a lot of duplicate values or repeated rows of data. Okay, so so suppose like I have so suppose I have a data set of students, right? Student IDs, right? So I have student IDs, or let me use this text box here. Okay, so I have a data set where I have student ID, I have grade, I have height, weight, and so I have a whole bunch of other features, right? So this is like a real life data set that you're gonna have, right? Like I have their attendance and so on, right? So I have all these columns of data, right? So suppose I have the student ID 119, 199, 119, 20, whatever. So I have some random numbers, right? So here's the thing, like, how do I eliminate duplicates? Okay, so when you do pandas, in pandas, it gives you a very easy way of doing this, which is called drop duplicates, right? So drop duplicates. But what pandas actually in the back it's doing is that it's identifying these rows of data as sets. Okay, it's essentially considering the whole data set as a set, and each element of the set is a row of data. Okay, so each element of a set is a row of data. Okay, and because it's a row of data, what's happening is that when you use set, when you use sort of the set command, it's essentially eliminating all the duplicates. It's just dropping all of those. Okay, so that's like an actual example where you see having or thinking about your data set, where each element of your each row of your data set is nothing more than a element of a set. That's how you have to think about data sets in general. And that's why they're also called data sets, because you can think of each row of your data as an element in a set. And then you can do a lot of these filtering operations, a lot of finding similar operations as sort of similar rows, different rows, and so on. They can all be thought of as set operations. Okay, and as we go through the set operations today, you'll start to see, like, so keep this as a mental image in your as you think about this, right? Keep the mental image of a data set, right? So because that'll help you really understand, okay, we're not just thinking about bananas, apples, and oranges here. We can actually apply everything that we're thinking about here to an actual data set. Okay. That didn't work. Oh. So this whole elimination of duplicates thing is an extremely important idea. Right? So any questions on this part? That didn't work. I guess the markdown works differently here. So any questions? I'll stop at this point and sort of let's think about these things. Let's think about questions like, does this logic make sense? Right? So let me give you another question as such, right? So if I have the following set, what should be the output here, right? So when I do print S2, what should it print? Yes, Hubert is right. One of his comments is there's a famous data science and data engineering interview question that requires you to remove duplicates in a set, duplicates in a list without using a loop. So that's exactly what this question is. Okay, so I have a list here. Okay, and I want you to remove the duplicates, right, in this. So what should this print? Anyone? Sidinia, it's been a while since we have heard your voice. Anyone? Can you guys guess?
It will print all the numbers in L.
Well, so which numbers will it print? So you're saying it'll print every single number in L.
1, 2, and 3.
So it'll print 1, 2, and 3. Okay, so that's one answer. What about others? Esther, any guesses? Do you agree with Sadinia? You don't?
I tried it and it didn't print anything.
Pardon?
I tried, it was empty.
It was empty. So
Yeah.
I tried this and it was empty.
Yeah. not-
Okay. Okay. So what happened here? It collapsed all the values, right? It just removed all, removed all the duplicates here, right? Removed all the duplicates here, removed all the duplicates here, right? So it didn't matter what order your numbers were in, right? So I could have L as something like this, 2, 1, 1, 2, 1. It doesn't matter like what order I have my my numbers in, right? Whatever it is, it's still going to give you the same answer, because it doesn't matter how many repetitions I have, and it doesn't matter what is the order of numbers I have. It's always going to give you 1, 2, 3, because what the set only cares about is it only cares about what are the unique elements, right? So this becomes extremely useful when you're answering questions where you want to identify what are the unique elements. Okay, and you only want to deal with unique elements. Okay, and and especially when you want to think about data in a structured fashion, you want to think about sort of the structured data and say that, hey, look, this is how, all these rows of data in a data set are similar. Okay, so I can think of them as a set. And now what I have to do is I have all these other rows from the same data set that I can think of them as another set. And then I ask questions like, which rows of data are the same in both these sets, right? So, and that's where like the set operations come, right? So this is how you play around with sets in Python, right? So this is how you declare a set. This is how you read a set. This is how you add to a set, right? So you can also sort of remove from a set, right? So I can say grapes, and then if I just do S, there's going to be no more grapes, right? Because it's been removed from the set. So this part is fairly straightforward. It's just add and remove. There's nothing fancy there, right? So let's ensure that that's set. So all right. So now comes another idea, right? So and I kind of alluded to this a little earlier, which is the idea of a subset. Okay, so this and the idea of a subset. So again, like a subset is fairly straightforward. So if I have a set where I have say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? A subset is nothing more than just a small part of it, right? So 1, 2, 3, 4 is a subset. Okay, that's just a subset. That's fairly straightforward. Okay, if I have, so we also have the idea of, so I can have, so this subset, right? So if this is set S, we say, so I'll call this S1. So we usually say that S1 belongs to S. Okay, meaning that I have this set belonging to the bigger set S. S1 being the smaller set, it belongs to the bigger set S. Okay, so you can take, so how many subsets can you take from this set? So I'm not looking for a specific number. I'm looking for, you know, okay, so let's start by asking this question. What's the smallest subset that you can take from this? Anyone? This is a fairly easy question. Think about it. It's not a trick question. What's the smallest subset that I can take from S? Mari, can you make a guess?
Maybe 1-digit number.
Yep, you're right. So the smallest subset is just like 2 or 3 or something like that, right? Single digit numbers, right? What's the largest subset that I can take from this? How much? 4?
Yes.
No, so okay, so you're saying no, so for the number or for elements in terms of the subset.
4 elements.
So why do you think it's 4 elements?
Because there is only 4 elements in S1.
I see. You're saying in S1, right?
Yes.
But what I'm saying is from S. From S, how many elements can you take?
Oh, 10.
Yep, exactly. So basically in some ways I can define an S2, right? And I can say that essentially this whole thing is a subset, right? That's what it is, right? So the largest subset you can take is the size of the set. The smallest subset you can take, actually, you know, I sort of, the smallest subset was a bit of a trick question, because the smallest subset you can take that exists is just 1 element, but you can also take something called a null set. Okay, so a null set is nothing more than a set with so we don't usually say it's 0. What they do is they'll put 0 and they'll slash it. That's saying that there's nothing. So that's the equivalent of saying that, you know, remember like when I was talking about set being like a box of fruits, right? So I have like bananas, apples, oranges, and whatnot. Suppose I take everything out, right? I just still have the box. That's a null set. Okay. So from the S that we have here, right? Apple, banana, pear, grape, oranges, and whatnot. If I remove all the elements, I still have a box, right? And that my box is my null set. Okay. And that idea is kind of important to keep in mind, because, you know, null, you'll see that null sets, you'll come across null sets all the time, especially like when you start looking at, okay, you know, how many objects are similar in two sets, right? So when you start thinking about that, you run into trouble, because sometimes there aren't any objects that are similar, right? So then you run into the trouble that, okay, I essentially have a null set, because I have a box which doesn't have anything. You know? So and that's what we'll do next, right? So suppose I have my big set S, which is all the numbers that I have, right? So which is all the numbers here. So, and I have S1, which is, so let's start going over set operators, right? So everything that I've covered so far, right, is defined in the notebook here. Okay, so everything that we did so far about what is a set, what is, you know, how do you define it in Python, everything that we've done so far is covered in this notebook, right? So, okay, I'll show you the command for Yeah, so I should have covered that as well. So so I have this. So suppose I want to check in Python, right? If something is a subset of something else, right? So I have, so first let's do print type S.
Oh,
Type
oh, I
S1.
want it. Oh, I want to zoom it out a bit.
Zooming out.
Yeah, I said I wanted to zoom it so that it can be clear. It looks like it's about small.
Oh, okay. It looks too small or it looks too large?
I don't know how everybody feels, but it looks small for me.
It looks small. Okay, how do I zoom into this? I have to figure out. Hold on. Let me figure out how to zoom into this.
That's fine.
Uh,
That's okay.
equals fine. Okay. No, I got it. Can you see it better, Hubert?
Yes, thank you.
Okay. All right. So far, like we have these two objects, right? Which we have S and S1, right? So S is a set, S1 is set. So how do you check that S1 is a super subset of S or not, right? So you just do dot is subset, and then you just do S, right? So it says true. So it's giving you a Boolean value, right? So the value it's giving you is of type bool. Okay. So a Boolean value is essentially something that's true or false, right? So so what you're getting by doing this is true, right? So next, I'll ask the question: is this a superset of S? So what do you guys think that the result of this should be? So let me just change that here itself. So is S1 a superset of S? Firstly, what is the superset? Anyone can answer that question? So if a subset is a small unit of, so if a subset is a smaller unit of a larger set, what do you think a superset would be? Any guesses? Esther, any guess?
It's like my mother.
It is like the mother. You're right. It is the mother. So S1 is like the child of S, right? So S becomes the mother of S1, right? So it's exactly that. But when I ask this question, is S1 the mother of S? That's not true, right? Like because S is the mother of S1, not the other way around. So the value that I should get is false, right? Because that's not the relationship that they have. So because S1 is basically a subset of S. Right? So so this idea is super important to keep in mind because so then if you want to check if S is a superset, you just type this, right? That's true, right? So this part, I hope this part makes sense. So I mean, this is just syntax. I don't want to spend too much time on syntax because this is something that you guys can go through the notebook and you can sort of get a sense of, okay, you know, this is how you do it. So play around with some of these examples. Conceptually, the idea is the same thing that I was talking about from the point of view of a mathematical set, right? And again, like here, we're just defining notation. So the more important ideas that I want to talk about are here, right? Like set operations. And set operations are super important because that's where you really start seeing like how powerful sets are, right? So let's start going one by one, right? So let's start with union of sets, right? So if I have a set 1, right, which is 1, 2, 3, and set 2, which is 2, 3, 4. Okay. Let me do 4, 5, 6, 8. Let's do. So these are my sets. I can do something like union S1, right? So what happened? It just combined both those sets, right? It just put those sets together. Does this make sense? It's just putting 1, 2, 3, 4, 5, 6 together. Now here is where it gets a little, it can get a little tricky, right? So I have a set where I have 1, 2, 3, and then I have 2, 3, 4, 5. What do you guys think the answer should be here? Anyone make a guess?
Just be 1, 2, 3, 4, 5. It will remove the duplicates.
Exactly, right? It'll remove the duplicates, right? So when you're doing a union, it's just going to remove the duplicates, right? So this is very useful because, so again, like going back to that example as a data set, right? So if I have rows of student IDs and I just want, when I combine them, suppose like, I have, I have a set of student IDs and then I have another set of student IDs. So think of it like, okay, I have student IDs set 1, which is, okay. So I have student ID set 1, and I have something like 119 or 110, 100, 200, 500, and so on. And then I have another set 2 of student IDs, another set, a row, basically like another row of set of rows of data. And then I have, say, 100, 102, whatever, right? So some set of numbers. So when I take the union of both of these, right, as sets and not as any other data structure, what I'm going to find is that it's going to eliminate all these duplicates, right? So it's just going to focus on giving me, 110, 100, 200, and 500. It's just going to eliminate those duplicates, and 102, right? So that's useful to know, right? So the real fun with sets starts when you start looking at things like intersections, okay? So an intersection is nothing more than, what are the similar elements in S1 and S2, okay? So an intersection is nothing more than, okay, these are the two sets of, this is the set of similar elements between S1 and S2, right? So when I do S1 intersection S2, what do you think? What do you guys think it should print out? Any guesses? Anyone?
2 and 3.
2 and 3. Okay. Let's see. 2 and 3. You're right. Okay. Awesome. So what about now? Anyone make a guess? What about now?
None.
Empty set, maybe.
So you're close. Like it is none, but it's a null set, right? So this is an example of a null set, right? Where you looked at objects in set 1, you looked at objects in set 2, and then you compared them and you said, well, there are no objects. So this is the equivalent of me having, me having 2 boxes, right? One has apples, oranges, and a banana. The other has pears, grapes, and pineapple, right? And then I'm asking, then I bring another box and I put it on the table and say, I'm going to take, the same fruit from both these boxes. I'm going to put it into this box. It's like, okay, doesn't exist because there are no two fruits in both these boxes which are similar, right? So obviously it is of no consequence. Like that box is just going to be an empty box, right? So in that sense, this operation is very, very useful because what it'll tell you is if two of your data sets are independent, right? So again, like going back to the student ID example, if you have certain student IDs which do not exist in both sets, right? Like they'll get eliminated, right? The only student IDs that you're going to keep are the ones that are there in both sets, right? And that's very, very useful, right? So and it helps to think about data sets in that context, right? That so this is a good way to sort of filter data, right? So based on student IDs, I can essentially like filter my data set and say that, okay, I only care about a range of student IDs that fall within, say, 100 to 200, right? I don't care about any other student ID within that range, right? So when I think of this range of between 100 and 200, right? Or this should be greater than, and this should be less than, right? So okay, yeah. So in this context, right? Essentially, what I'm actually doing is I'm saying that I have a separate set of student IDs which go from 0 to 100, and then I have a separate set of student IDs that go from whatever is the maximum number to 200, and I have my upper bound for it, I have my lower bound for it, and any number that falls between these two ranges is just not going to belong. So if I have a set, right, that I define of student IDs with this filter, right? So I'm going to have all student IDs not that are between 101 or between 100 and 200, right? So if I take the intersection of that with, with this set, it's just going to give me a null value, right? So this is a good way to filter out data. Okay, so there's a good way of thinking about filtering out data, right? So that's useful, right? So that's one thing. So what's the next set operation, right? Yeah, intersection of set, difference between sets, right? So so if I take S1, right, and if I do S1 minus S2, I essentially will get S1 because when I subtract it from S2, there are no elements that are being removed, right? So that's an issue, right? Because there are no similar elements. But if I do this, right, now I have common elements. I have 1, 2, 3, and then I have 2, 3, 4, 5. So when I do this difference, right, it's going to give me 1, because what it's going to do is it's going to look at S2. It's going to look at what are the most common elements, and then it's going to subtract those common elements from S1. Okay, and when it subtracts those common elements, it's essentially just going to give me a set without these elements in S1. So I can also do the opposite direction. So if I do S2 minus S1, what do you guys think the answer should be?
We'd get 5.
So you'll get 5, but there's also another number, right? That's not an S1. 4, right? So you're gonna get 4, 5, because what's gonna happen is so 2 and 3 are common in S1, and then 2 and 3 are common in S2, and it's just going to subtract both of those, right? So it's just going to remove both of those, not subtract. It's going to remove both of those, right? So and that's why you just get 4 and 5, right? So difference is a pretty useful tool as well, because again, like it helps you remove data when you don't want a specific set, right? So and you know, so all these sorts of operations are fairly useful when you're thinking about set, right? So and then, like, you know, you have symmetric difference, which is essentially given two sets, you can you can look at, like, okay, what are all the elements which do not which are essentially common, and it's just going to remove those, right? So let's look at this example. So what are the elements that it's decided to keep in this, right? So when you take the symmetric difference, it's decided to keep like 0. It's decided, so from set 1, it's decided to keep 0. It's decided to keep 6, and it's decided to keep 8, right? From set B, it's decided to keep 1. It's decided to keep, what else did it decide to keep? 5, right? And 2, 3, 4 are, you know, so it's also decided to keep 3, right? So 2, 4, 2 and 4 are there in both sets. So when you took the symmetric difference, what it's done is it's essentially like done the opposite of intersection, right? So when you did intersection, what you did was you only kept the numbers that were common to both, right? So if you took the intersection of A and B here, right? So let's actually do that. So let's do intersection, right? So if you did A intersection B, oops, stick there. Yeah. So when you look at the intersection, what you've actually done is you just have 2 and 4. So those are the numbers that are the same, right? But what the symmetric difference is actually doing is it's doing the following. Okay, it's saying, let me do A plus B, okay, minus this, right? Okay. So you do A union, right? That's what it's doing. Okay, so it's doing A union B, and then it's subtracting the intersection from it. That's all it's doing, right? Is this part clear? So okay, if I do the so if I do this, right? If I take these two, and if I do S1 symmetric difference S2, what do you guys think the answer should be?
1, 4, 5.
1, 4, 5. Okay, let's see, 1, 4, 5, and you're right. Okay, because what it's done is it's essentially thrown out these numbers, and then it's essentially played around with. It's just kept the numbers that are common in both sets, right? So again, like another sort of very simple example, going back to our so far I've been playing around with numbers, right? So let's go back to our original set here. Right, and we're going to call them fruits. So in numbers, you know, it was a little easier because numbers, you can think about them, but let's start playing around with them. Let's start playing around with letters or words, right? So, and I'm going to have a set of vegetables, or I'm going to have another set. I did something here that's a bit on the trickier side. So let's see. So I made two mistakes in declaring this set. What are the two mistakes I made for L2? I made those mistakes intentionally. Esther, can you take a stab at it? Grab at least one mistake out of it. You don't have to point out both. No? What about Mari?
I don't see any mistakes.
So the first mistake I made was carrot is not a fruit, right? I'm declaring a set of fruits, right? So remember, when we talked about sets, we want to have objects which are similar, right? Because if I'm looking at, like, obviously I cannot do an intersection of vegetables and fruits, right? So if you look at an intersection of fruits dot, intersect vegetables, right? What are you going to get? What will, like, all the fruits in the world intersecting with all the vegetables in the world? What are you going to get?
A tomato.
Very funny. Okay, I will accept that. Accept that answer. Yeah, I mean, you'll get a tomato, but technically speaking, you're going to get a null set, right? A tomato is an acceptable answer because of the confusion of whether it's a fruit or a vegetable, right? So basically the idea is that these are two sets that that may seem similar, but they are different. Like they have like different types of objects. So in L2, right, having carrot doesn't make sense. So unless, like, I decide to call this set something else, right? Like I define the set as something else, as consumables or something like that, right? Like non-meat consumables, right? It's like vegetarian foods or something like that, right? So, but if I'm going to define it as fruits, I cannot define this as part of the set. So this is something that, this seems like super elementary, but this is something you guys need to keep in mind when you're thinking about data sets, right? So when you go to combine data sets, right? So suppose, like an example of this, let's go back to the student IDs, right? But suppose I'm doing, I'm collecting this data from school A, right? So I'm collecting all these student IDs from school A, right? So if I'm going to be doing that, right, I should not be mixing the data with school B. Like I shouldn't be mixing the student ID data with school B, unless and until I clearly, like, of course I can mix it, but I need to understand that there's difference between these two schools, because the locations are going to be different, the kind of students, like the neighborhood that, sort of the average income in the neighborhood where they are, it's going to be different. The access to certain services, it's going to be different. The demographics of the people who are going to be there is going to be different. So from the point of view of a data set, right, you need to be aware of this, right? So it's perfectly acceptable to combine these data sets, but you need to understand, you need to keep in mind that when you're combining these data sets, you're going to change the definition of that data set to a large extent, right? So when you combine, like, for instance, all the fruits in the world with all the vegetables in the world, right? you're not going to come up with a set of fruits, right? You're going to come up with a set of fruits plus vegetables, and you're going to have to call it something else. And any sort of statistics that you pull from, fruits, right? So for example, if you pull like the average sweetness of fruits, right? Like you have a measure for sweetness on a scale of 1 to 10, right? That statistic is going to be vastly different for veggies, right? And that's why you don't combine data sets simply, right? Because you're, some things are going to be same, right? Like the average size of fruit, most fruits and vegetables is approximately the same, right? They're on the order of like, they're on the order of tens of centimeters, right? But when you think about it from the point of view of like some other metric, right? Like sweetness, for instance, obviously fruits are going to be sweeter than vegetables, right? So you need to think about like what metric that you're thinking, what sort of feature that you're thinking about, or what metric you're thinking about, and how that pertains to the entire data set, right? So you like in case of school A and school B, you might think, okay, well, student ID is the same across all schools, right? Like I mean, they'll have some random definitions, but how they assign students IDs might be entirely different, right? Like the process they use might be entirely different. So although it might look like it's the same column of data, the process of how they came up with that number might be entirely different, and that can create problems when you're thinking about data, right? So you have to be very careful in thinking about, okay, where is this data coming from, right? And that's super important. Does that make sense? Yeah. So that part is like fairly straightforward, right? So let's see, where are we at? So we covered this. We covered almost all of it. Don't worry about group theory. Nothing in the lab has anything about group theory. We have to remove this at some point. The group theory is, so I mean, group theory is like a field of math where essentially when you have sets, you can then sort of define like a set of you can define a collection of properties for a given set, and when they meet a collection of these properties, you call it a group. Okay, so for instance, like here are all the properties that you have to match in order to be for a set to be called a group. Okay, so if it matches all these properties, then you say that it's essentially a group. But I mean, in machine learning, like you do use groups, but it's not that prevalent. It's not like literature that, or it's not nomenclature that you're going to come across in interviews so much. But what the core focus is that you need to understand like what is a set. You need to understand what these set operations are. Okay, so that's the main part. So any questions with what we have covered today so far? Anything like intersections don't make sense, or the definition of a set doesn't make sense, right? Nope. Okay, so what I'm going to do is, so normally what I would have done is I would have just gone through the lab in this class. Since you guys seem to have understood every single thing, what I will expect you guys to do is I want you guys to attempt the lab. Okay, I want you guys to attempt the lab, finish it, and I want someone to walk us through the entire, not through the entire lab. They can walk us through like parts of the lab, right? They can walk us through like the first 2-3 cells, and then another person can walk us through 2-3 more cells, and so on, right? So what I want you guys to do is I want you guys to attempt the lab. Okay, so next class when we start, we'll focus on the lab, right? I want to see people actually, they should have done the lab, and they should have had the answers ready, and they should be able to walk through. You should be able to walk each other through the lab, okay, without me having to provide any instruction, right? So what I want you guys to do is I want you to focus on that. And next class when we come in, that's like the first thing that we're going to do. Okay. We're going to spend as long as it takes to make sure that this is done. Does that work? Well, is everyone okay with that?
Yes.
Yes. Okay.
Yes.
Awesome. Camille, are you also going to do the lab? Okay, Camille's not around. All right. So Hubert, they have access to like the lab and everything, right? So
Yes.
they should be able to do that. Okay.
Well, if you don't have access, I just share my email. You can send me an email. We'll figure out.
Okay. But yeah, so again, like remember, everything is accessible on Refactored. Like even if you don't have access to it on app.colaberry, it is accessible on Refactored. Okay. So you can come to Refactored and you can essentially like work through all of these things. Okay. You can come here, you can look at the notebook. Okay. So you literally just go to refactor.ai, right? And then to find the lab, just go to your data science 2, your algebra, set operations, coding lab, right? Right. So it's that easy. Okay. I would highly advise so. So the question is, do we have to record videos for Refactored? Okay. Yes, please do. Okay. Please do record videos because it'll help you learn, right? So I've sort of walked you through like what's there in these sections, right? So what I expect you guys to do is go over this stuff again, right? And start your video lab where you just talk about like what you've learned, right? So basically talk through like, okay, talk through the following questions. What is the definition of a set, right? What is the definition of a set? Define it in your own words, right? And define like what is the intersection operation, right? Like define what is a subset, define what is a superset, define what is a symmetric difference in a set, right? So define these things in your own words, right? Don't look it up. See, the best way to learn, right, is to actually teach yourself on video. Okay, it works wonders because when you start talking about what you know, right, you'll realize like what kind of loopholes in your understanding you have, right? So for example, you know, I mean, when I learned all of this stuff, it wasn't clear to me how well I knew. Like I could manipulate the, you know, I could play around with sets and I could, you know, think about it from a mathematical point of view. But when I was forced to give presentations, right, when I was forced to talk in front of my entire class, it became necessary for me to actually understand what was going on because people ask questions, right? So keeping that in mind, since we can't do that due to the pandemic and whatnot, and in general, since like learning online has become such a norm, the best way to sort of mimic that is to actually go record a video, right? And we provide you that service here, right? You can record a video here, or you can upload a video. And what you're going to get is you'll get some feedback, and I'll explain that feedback once you get it. But the basic idea is that the basic, you know, just the basic act of recording a video will help you identify where your lack of understanding comes, right? And you might think that you understand everything that I've covered here today, but 90% of the time that's not the case. You'll always have questions about these things, right? So and this section, the set section, is a fairly easy one, right? From next section it gets really complicated because we start then, you know, looking at things like vectors, right? So what I'll do for the rest of the class is like I'll give you guys for some 10-15 minutes. I'll give you guys a rundown of what comes next, right? So sets are like one side of how to think about data. Okay, so there's one way. So sets are one way of thinking about data, right? So and that's where I gave you guys like the examples of rows and how you have similar rows or dissimilar rows in a set and whatnot, right? So that's one aspect. The other aspect is when you start thinking about data from the point of view of vectors and scalars and so on. Okay, so basically dimensions of data, right? So and this is stuff you might have covered in high school. You might have learned like what a vector is or what a scalar is, but when it comes to sort of data, when you start thinking about data in terms of vectors and scalars, it becomes really, really useful, right? So the most common vector you would have heard of is like velocity, right? Or speed, like so speed. So speed is not a vector. So speed is a scalar. So speed just tells you how fast you're moving, right? But velocity is basically something where velocity is a quantity where it essentially tells you how fast you're moving, but it also tells you what direction you're moving in, right? And that direction adds dimensionality to that data, right? So because that direction means that you're either moving in the x direction, the y direction, or in the z direction. Either you're moving sideways on a plane, or you're moving up and down, right? So that dimensionality is added. So you can actually think of data in the same way, right? So again, going back to my example of a data set of students. So remember, I mentioned you have school ID, you have height, weight, and so on, right? So you can actually think about height, weight as dimensions, like x and y dimensions, just like spatial dimensions, right? So height is an independent dimension that goes from 0 to say whatever number, and weight is another dimension which goes from 0 to say whatever number. And you basically, like, your entire row of data can be thought of as a single point in this space, right? So for now, and the label of that point is the student ID. Okay, so I can color that point with a student ID and say that this is the unique student ID, right? So we're going to start thinking about data as having dimensions, right? And once data starts having dimensions, what you can then do is you can apply the entirety of this field of mathematics called linear algebra, okay? And what linear algebra lets you do is, when you have these objects called vectors, right? You'll be able to essentially manipulate vectors. You'll be able to change the direction of vectors. There are ways of like transforming them. There's ways of like adding vectors, subtracting them, doing all sorts of fun things with them. And so and you can do all of this to data, right? And that's what a lot of once you understand the logic, what you'll learn is like that's what a lot of machine learning algorithms actually do. Like in machine learning and data science, that's what people do, which is they take data as vector quantities, and then they manipulate it, they play around with it to get more useful information. Okay, so that's sort of a general idea of like what's going to come with linear algebra, and it's a very, very long section, and there are some really like complicated pieces that we'll have to cover, right? So what I want you guys to do is spend some time, do the lab, get your feet wet, start thinking about things, in terms of sets. And we're next class, we're going to first focus on spending time, finishing up the lab, and then we're going to jump straight to linear algebra. Okay. Do we have to still submit the assignments of Colaberry app or working? So you will have to submit them on Colaberry app. So to make your life easier, basically, when you finish your coding lab, right? What you can do, so what you can do is, let's go to coding lab. Let's pick this, okay? It's gonna open up. You're gonna finish your coding lab, right? Then you should be able to download it, okay? It's gonna give you an HTML file, okay? This HTML file, you have to fill your, so you fill your solutions here, okay? You fill, so the coding lab is like, it's like fill in the blanks, okay? So you go in, you have a question. So usually there's like, there's stuff left over, right? Oh, I think this one actually has the solutions. My version will have solutions because I've actually solved it. But in your version, what's going to happen is you're not going to have solutions. So you're not going to have things like this, right? So what you have to do is you basically have to fill in the blanks, okay? And once you are able to fill in the blanks, it's going to, just make sure you check the answer. And if the answer is wrong, we can discuss it like as to why it's wrong. It could be that the answer that I've given could be wrong. So that's something for you to think about as well. Is your answer correct versus my answer, right? So that's something that you can think about as well. So basically, once you do this, right? Once you do the coding lab, just go to File, then Download As, and it'll give you an HTML file. That'll download straight to your computer, and that's the version that you can submit to app.colaberry. Okay. All right then. So that's all I have for you folks today. Let's catch up on Wednesday. Okay. Make sure you do the coding. Make sure you do the coding labs. Okay.